What's up everybody, this is Teacher Ivan from NextGen Academy. Our goal in this channel is to help you achieve your highest potential and to help you understand subjects in the easiest and the most efficient way. If you'd like to get more tips and tricks on how to achieve A star in your IGCSE, don't forget to like, comment, share and subscribe to this channel. Lastly, if you need any help in your studies, you can always head on to our website, link in the below, or our Instagram, drop us a DM and we'll be able to help you. Enjoy this video and I wish you all the best.
Okay, welcome back, my NextGen family. Okay, today we're going to go through the second half of this paper, October-November 2024, paper 1-2. Okay, so we're going to continue from where we left off. Question 6. Okay, question 6a. Find in descending powers of x the first three terms in the expansion of x plus 2 over x squared. Simplify each term as far as possible. Okay, so this is your binomial expansion, okay, or binomial theorem. First thing, if you don't know the formula, you go into your formula sheet. Okay, your formula sheet right now it looks maybe a little bit different already. Slightly different, okay, because got extra formula. But this will still be given to you. Okay, you all write this down into the question first. Okay, just copy it down first so that y'all can refer to this. Everyone knows how to apply this. A plus B to the power of n bracket a to the power of n. Okay, what is that bracket? Okay, this will be under paper 2. You use calculator. Okay, you'll use calculator to do this question. So we will categorize this as a paper 2 question. Okay, they want it in descending power. Okay, we read this. Descending power. How to do descending power? This is your A. This is your B. Okay, you have to identify for this specific form also because this one is x and 1 over x squared. I want you all to just focus on the x first. Okay, can we just straight away put into the formula and then it comes as a descending power of x? Can, right? Okay, can just put inside, right? Okay, so I want you all to straight away just substitute inside. The first term will be a to the power of n. So x to the power of 10. Okay, the first term, x to the power of 10. Then plus n1 means nc1 a to the power of n minus 1. So 10 minus 1. Then the second term will be b to the power of 1. Okay, just remember that the power always balance up to become equals to 10. Okay, so technically we're just putting into the formula only. Second one, 10c1, or you can put bracket 10(1) x to the power of 9, 2 over x squared to the power of 1. Okay, 3 terms. Third one, 10c2 x to the power of 8, 2 over x squared to the power of 2. Okay, then I want you all to open up the bracket and also type into the calculator your 10c1, 10c2. Okay, first one, x to the power of 10. 10c1 will be 10 times x to the power of 9. And then 2 over x squared plus 45x8 times 4 over x to the power of 4. Okay, simplify it. X to the power of 10 plus 20. 9 minus 2, x power 7 plus 45 times 4. 180, x to the power 8 divided x to the power 4, x power 4. Okay, this will be your final answer. x10, 20, x7, 180, x4. Okay, this one easy, 3 marks question. Okay, question B. Find the term independent of x in the expansion 4x squared plus 1 over 2x squared to the power of 8. Okay, what does it mean, independent of x? Okay, independent of x. All right, no x, it means x to the power of 0. Okay, you don't want any x to exist over here. Okay, so we first have to determine, based on this 2x value with this power, what is the combination that will give us x to the power of 0? Okay, this one I think is quite easy to identify because you got x squared and 1 over x squared. Okay, so if we put x squared times 1 over x squared, okay, we need to put the power that both of them add the power will become equal to 8. So it can either be like this 0, 8, 1, 7, 2, 5, 3, sorry, not 2, 5, 2, 6, 3, 5, 4, 4, okay, so on and so forth. Right. You write down all the possible combination, but this one is quite easy because the power is already the same. So you just need to put it as x power 4, okay, x squared power 4 and 1 over x squared power 4, because x squared power 4 will be x to the power 8, 1 over x squared to the power 4 is 1 over x to the power 8. Okay, so we put now into the formula, it will become 8c4, 4x squared to the power of 4, 1 over x squared to the power of 4. Okay, sorry, 1 over 2x squared to the power of 4. Yeah, before, when you're determine, you don't care about the coefficient first. You all just look at the power first. That's the main thing. Okay, take out your calculator, type in 8c4. This will be 70 times 256 x to the power of 8 times 1 over 16x to the power of 8. Okay, x power 8 and 1 over x to the power 8 will cancel off. Then you just take all the values. 70 times 256 divided by 16. You get 1120. Okay, I think this is a relatively easy question. Question 6. Okay, if you can do question 6, can you type 6 in the chat? Okay, anything to clarify, please ask me. Okay, good. See all the 6 in the chat. Very good. Okay, no question, huh? Okay, let's move on to the next question. Okay, question number 7. It is given y equals to ln 3x squared over x plus 2 for x more than 1 over x squared, 3. When x equals to 1, y is increasing at a rate of h units per second. Find in terms of h the corresponding rate of change in x, giving your answer in exact form. It's a 6-mark question. Okay, what question is this? What type of question is this? And what are the keywords over here? Okay, anyone knows what's the keyword for this question here? Okay, because we have to plan, what do we want to do? Okay, rate of change. Do you all see the word rate of change? Okay, so there's only one section in your entire your syllabus, your MS syllabus, where got rate of change? Under differentiation. You all recall that? The application for differentiation, okay, on rate of change. Okay, for rate of change type of question, okay, under differentiation, what do we need? Okay, what type of equation we need? Because you all need to remember all the type of methods for the application part. Okay, we need 3 derivative. Very good. Okay, 3 derivative. So you need to construct. Okay, actually it can be 3 derivative or more. You can write like that: a over b times b over c equals to a over c. Okay, you want to write down 3 derivative. That means 3 d something over d something. Then you put it into one equation. Okay, you put it into one equation. Okay, we see what is given to us. Sometimes we have to go and find from the shapes itself. Sometimes it's just from the formula itself. Okay, from here, we can find dy over dx based on this equation. We can say here y is increasing at a rate of h units. So this is dy over dt. And then they want us to find rate of change in x, which is dx over dt. Okay, so you got y, x, and t. Okay, let's find what is dy over dx first. Okay, from this question, y equals to ln 3x squared minus 1 over x plus 2. We are going to use quotient rule. Okay, because this is u over v. U is ln 3x squared minus 1. V is x plus 2. U prime. Okay, this one, you know how to differentiate. F prime x over fx. So 3x squared will become 6x. And here 3x squared minus 1. V prime will just be 1. Okay, quotient rule. So you will use dy over dx equals to vu prime minus uv prime over v squared. Okay, vu prime. X plus 2 times 6x over 3x squared minus 1 minus ln 3x squared minus 1. Okay, times 1. We don't need to write the times 1. Okay, let's just write ln 3x squared minus 1 over v squared, x plus 2 squared. Okay, from here, I don't want you all to simplify further, okay? Because this type of equation, they are not asking you to differentiate and then find into a certain form. They want you to find the value itself of the dy over dx. So over here, you just make a remark, okay? Don't go and simplify. The more you simplify, the more mistake you'll get, okay? Unless they ask you to show into a certain form, then you simplify it. Otherwise, you will just leave it like this. Okay, now, we are going to do substitute x equals to 1. Okay, we're going to substitute x equals to 1. So at x equals to 1, your dy over dx, you can straight away put in the values, will be 1 plus 2, 6 over 3 minus 1 minus ln 3 minus 1. Okay, 3 minus 1 or ln 2 over 1 plus 2 squared. Okay, by the way, this step is not even necessary actually. You want to straight away put in the value also can. Okay, but this specific question can potentially come out in paper 1. Okay, so here will be 3, 6 over 2 minus ln 2 over 3 squared. Okay, we'll get here 9 minus ln 2 over 9. Okay, this is your dy over dx. Okay, what do we want? Okay, what's the equation that we want? And what is given to us? Okay, they give us y is increasing at a rate of h. Rate means over time. So they gave us here dy over dt equals to h. And then they want us to find rate of change of x. So dx over dt, we don't know what is it. Okay, we've got these 3 derivative here, dy over dx, dy over dt, and dx over dt. Can we construct a chain rule out? It means an equation to relate these 3 derivatives. Okay, we can write it as dx over dt. Okay, we want x to be on top, so we can write it as dx over dy multiplied by dy over dt. Okay, you can treat it like a fraction where you can just flip it. Okay, just flip the value. Okay, what's dx over dy? We found dy over dx, so this one we can just inverse the numerator and the denominator. This will become 9 over 9 minus ln 2 multiplied by h. That's all. We can write it as 9h, 9 minus ln 2. Yes, this under differentiation, okay? Under your differentiation 1, but differentiation 2 formulas is the application part. Okay, number 7. If you can understand this, can you type 7? 7 in the chat. Okay, 7, 7, 7. Okay, easier so far. Okay, number 8. Let's go to number 8. The tangent to the curve y equals to e power x 2x plus 5 power 1 over 2 at the point where x equals to 2 meets the x-axis at the point x and the y-axis at the point y. Find the coordinates of the midpoint xy, giving your answer in exact form. Okay, this is a potential paper 1 question also because they want you to put it in exact form. Okay, this type of question also very scary. Why? 1 sentence, give you 8 marks. Oh, okay, you wrong halfway, the whole thing will be wrong already. So be very careful when you all do this. Okay, what do we need to find first? Tangent to the curve. Okay, so we want to find what is this tangent line first, the equation of the tangent line. Equation of tangent line, what do we need? We need gradient. Okay, yes, we need m, very good. And we need 1 point, right? X and y. Okay, so you need to find these 3 things first. Sometimes they already give it to you. All right, so let's find our m value first, which is your dy over dx. Okay, so we use this u and v. U is e to the power x. V is equals to 2x plus 5 to the power of 1 over 2. U prime, e to the power x. Okay, nothing changes. V prime, 1 over 2, 2x plus 5 to the power of negative 1 over 2 times 2. Okay, we can simplify it. This will become just 2x plus 5 to the power of negative 1 over 2. Okay, we're going to use, this one is under product rule. So dy over dx is uv prime plus vu prime. Okay, uv prime plus vu prime, which we will get here, uv prime e to the power of x, 2x plus 5 to the power of negative 1 over 2 plus, okay, I put the e to the power x in front first, 2x plus 5 to the power of 1 over 2. Okay, back to the question again. Do we want to simplify this? Necessary for us to simplify or not? Don't need, right? Okay, we are not trying to find dy over dx form. We want to find the value of dy over dx. So you are just going to substitute the value inside. Okay, what's the value? They gave us x is equals to 2. Okay, so you need your value of m when x equals to 2. You need your value of y also. Okay, so here, at x equals to 2, dy over dx will be e to the power of 2. Okay, I will just substitute straight away from here. 2 times 2 plus 5 to the power of negative 1 over 2 plus e to the power of 2. 2 times 2 plus 5 to the power of 1 over 2. Okay, we simplify this. Here. Okay, hold on a minute. Okay, here we will get e to the power of 2. 4 plus 5, this will be 9 to the power of negative 1 over 2 plus e square, 9 to the power of 1 over 2. Okay. Can I simplify? This one will be e square over, okay, I'll write it into this form, 1 over 3 e square plus 3 e square. Add up together will be 1 over 3 plus 9 over 3, which is 10 over 3 e squared. Okay, all this can do without calculator. Okay, so dy over dx also represents the m value. Okay, so this is your gradient. Okay, gradient m. We want to find what is the y value. So y, we substitute in x equals to 2 into the y equation, which will give us e to the power of 2, 2 times 2 plus 5 to the power of 1 over 2. Okay, 9 to the power 1 over 2 will be 3, so 3e squared. Okay, I just write this as m. So we will get this value and this value. And also x equals to 2. Now, we are going to find equation of tangent. Formula that we're using is straight line, which is y minus y1 equals to mx minus x1. Y minus 3e squared equals to 10 over 3 e squared x minus 2. Okay, I like to put it into y equals mx plus c. So we rearrange it. 10 over 3 e squared x minus 20 over 3 e squared. Okay, we can bring the e square here to the right hand side plus 3e squared. Okay, minus 20 over 3 plus 3, we will get plus 9 over 3, so minus 11 over 3 e squared. Okay, all good until here? Equation of tangent. Okay, from here, now we see what else they say. The equation of the tangent meets the axis at point x and then at y. you straight away put into y equals mx plus c. Can also. Can also, but you have to find c first, right? So for you is you find c first. Okay, no problem. But you have to know that normally the mark scheme actually use y minus y1 equals to mx minus x1. So to be safe, use the maths formula lah. Okay, that's my advice. Not wrong, but just to be safe. Okay, now what are we going to do? We need to find our x and y, which is our x-intercept and y-intercept. Okay, so we're going to substitute at y equals to 0 and then x equals to 0. Okay, we're going to use this equation here. I just bring it up. Okay, we put this equation and y equals to 0. Okay, let's solve this. 0 equals to 10 over 3 e square x minus 11 over 3 e square. Okay, we got 11 over 3 e square equals to 10 over 3 e square x. E square and e square will cancel off. Okay, this one cancel. Then 3 and 3 also can cancel. So 11 equals to 10x. X is equals to 11 over 10. Okay, so this is the x value, x point. Y at x equals to 0. Therefore, y is equals to minus 11 over 3 e square. Okay, so this is the two values of your x and y. Okay, so x point, if you want to write as a coordinate, it will be 11 over 10, 0. Y will be 0 minus 11 over 3 e square. Okay, now we want to find what is the midpoint. Okay, midpoint formula will just be x1 plus x2 divided by 2, y1 plus y2 divided by 2. So final one, midpoint of xy. Okay, we're using this one, x1 plus x2 divided by 2, y1 plus y2 divided by 2. 11 over 10 plus 0 divided by 2. 0 minus 11 over 3 e square divided by 2. Okay, so you just need to take the denominator divide and times 2. So we'll get here 11 over 20 minus 11 over 6 e square. Put it in point form, which is a bracket like this. All right, okay, number 8. If you are good for number 8, can you type 8? Hey, no issues? Yeah, this one, I think quite straightforward still. Just be careful, okay, when you calculate. Okay, let's go to number 9. Another one sentence, 8 marks. Okay, this is on integration. Okay, I think this one potentially, both paper 1 and paper 2 also can come up. Okay, if really paper 1, this type of question comes out, right? Like the previous one, you have to really just be careful, okay, when you calculate, because you can't do it without a calculator. Okay, let's see this integration question. The diagram shows part of the curve y equals 4 over 2x plus 1 and the straight line 2y equals to 6x plus 1. Find the area of the shaded region. Give your answer in the form a plus ln a plus b. Then a is an integer, b is a rational number. Okay. Integer and rational number. So this means you can do without calculator. Okay, what's the first thing that we want to find? We've got two lines here. Sorry, we've got two equations here. One is a curve. Okay, this one is a line. A curve and line. First thing, we want to find what is the point of intersection over here. Okay, to do point of intersection, we'll do a simultaneous equation. Point of intersection. Okay, we're gonna do this one equation 1, equation 2. So we can sub equation 1 into equation 2. We'll do 2y, so 2 bracket 4 over 2x plus 1 equals to 6x plus 1. Okay, simplify this whole thing. 8 over 2x plus 1 equals to 6x plus 1. Multiply it up, 6x plus 1, 2x plus 1. Open out bracket. This will be 12x squared plus 6x plus 2x plus 1. Where we get here, 12x squared plus 8x plus 1. Okay, is it 1? Okay, 1, right? Oops, here. 12x squared. Okay, then we bring the 8. Okay, bring the 8 over to the other side. So here become 12x squared plus 8x minus 7 equals to 0. Okay, then we solve it. 6x plus 7. 2x minus 1 equals to 0. X is negative 7 over 3. X is equals to 1 over 2. Okay, so we will only take this one. Okay, this one we reject because if you look into the graph, x is at the positive x. Okay, so we don't care about the negative one. The negative probably is intercept at somewhere else. Not negative 7 over 6. Oops, correct. Okay, negative 7 over 6. Okay, you gotta reject it anyway lah. Okay, everyone good until here? Okay, so we'll take x equals to 1 over 2. Now we find what is the y value. Okay, which equation will be easiest to find the y value? Okay, either sub into here or sub into here. Up to you. Okay, let's sub into equation 2. Okay, so let's find sub x equals 1 over 2 into equation 2. So here will be 2y equals to 6. 1 over 2 plus 1. 3 plus 1 will be 4. Okay, then here y equals to 2. Okay, y equals to 2. Okay, now we know that this point of intersection will be equals to 1 over 2, 2. Okay, this is what we are finding. Okay, 1 over 2, 2. What else do we want to find? Okay, so we have to now plan. Actually, by right, we should plan from the start. Okay, what is the method that we're going to use for finding the shaded region? Okay, so we can see here, we can take the area under this graph here, from here to here, minus off this trapezium. Okay, minus off the trapezium. So trapezium, we've got here, this length. Now we need to find this part here also. Okay, this part here means we want to take this equation of this straight line, x is equals to 0. Okay, so let's do this one. We substitute x equals to 0 into equation 2 also. So here will be equals to 2y equals to 0 plus 1, y equals to 1 over 2. Okay, so this part here is 1 over 2. Okay, since we want to find this area, okay, what's this area of this trapezium? Okay, which is your area under the line. Area under line. Okay, which we can say a trapezium formula. So we use 1 over 2 a plus b times height here. Okay. This part is your height, which is equals to 1 over 2. Okay, then your a and b will be here, 1 over 2 and 2. Okay, so 1 over 2 these two add up together times height, which we will get 1 over 2, 2 plus 1 over 2 times 1 over 2. Okay, calculate this. This would be 1 over 2, 5 over 2 times 1 over 2, 5 over 8. In exam, don't need to squeeze so much, but try to put it in this small section here. Okay, so now we need to find the area under the curve. Okay, area under the curve. We will need to integrate, do a definite integral from 0 to this part here, okay, which is 1 over 2, okay, 0 to 1 over 2 for this equation. So, area under the curve, it will be this formula. Integrate from 0 to 1 over 2, 4 over 2x plus 1 dx. Okay, do you all know how to integrate this? 4 over 2x plus 1 dx. Okay, we have to recap back what we learned for integration of, okay, which integration will it be? 4 over 2x plus 1. This one, often students make mistake. Okay, so common mistake that students would do is, students will take this, go and change it to chain rule. That means you bring it up as 2x plus 1 to the power of negative 1. Because you're thinking in terms of differentiation. Okay, this is how we identify. Yeah, okay, very good, Ethan. Okay, 1 over x. So you want to think of it down here, if your denominator is all power 1, it means x to the power 1, then here also bracket to the power 1, we think about ln. It will be 1 over a ln ax plus b. Okay, like this. Okay, so how would I simplify it? You bring out the 4 first. Okay, don't care about the 4 first. Like that, easier for you to see. 2x plus 1 dx. Okay, so this is 1 over ax plus b. It will become 4, 1 over 2 ln 2x plus 1 from, what's the value? 0 to 1 over 2. Okay, from here, we can actually do this also. You can simplify this and this. Okay, so you just do the ln 2x plus 1. Okay, do like that. Ln 2 times 1 over 2 plus 1 will be ln 2, then minus ln 1. We end up with 2 ln 2. Okay, ln 1 will just be equals to 0. 2 ln 2. Okay, we take these two values, so the area under the line and area under the curve. So, area of shaded will be area under curve minus area under line. Okay, area under curve minus area under line. So, it will be 2 ln 2 minus 5 over 8. Okay, this is not the final answer yet. They want us to put it in ln A. Okay, that means no value in front. A is an integer. So we use power rule, bring the 2 to here. 2 squared. So it becomes ln 4 minus 5 over 8. Okay, number 9. 8-mark question. You can do this, type 9 in the chat. Wow, now I can finally understand. Okay, very good. Okay, when you all practice, then you can understand already. Okay, they all feel your, okay, as compared to last time, or improve already, right? So the more y'all do, you'll see the pattern to it. Okay, any question? Just now a few of you said cannot do 9. Okay, number 9 I think is okay. Okay, number 10 is the one that is a little bit hard. Okay, especially 10B. Okay, let's look at the question. All right, okay, question 10A. The first three terms of an arithmetic progression. Okay, they give you these values. Find the values of x, where x is from negative 180 to 180, for which the sum of the 30 terms, sum to 30 terms is 455 cert 3. Okay, for arithmetic and geometric, what y'all can do is also go and take down the formula first from the front. Okay, then if you don't know how to do, you figure out from here. Okay, so you see, arithmetic, just put down here first. This is your arithmetic series formula. Okay, what did they give us? They say sum to the 30 terms is 455 cert 3. So we will use this formula. Sum to 30 terms. So S30, okay, there are also two formulas here. Normally we will use this one. Okay, because this one they gave us first three terms only. So we use specifically this formula here. N over 2, 2a plus n minus 1d. Okay, so Sn, n over 2, 2a plus n minus 1d. Okay, we need our a and d first. A will be 2 tangent to x. D, you will use the next term minus the previous term. 5 tangent to x minus 2 tangent to x, which is equals to 3 tangent to x. Okay, we substitute into this formula here. S30 equals to 30 over 2, 2a, 2 tangent 2x plus n minus 1. So your n is 30, so 29d, 3 tangent 2x. Okay, they say that this is equals to 455 cert 3. Okay, all right, here, 455 cert 3. Okay, looks complicated. We do one step at a time. This one need calculator. Okay, this one will be a paper 2. Okay, so please take out a calculator. Okay, let's solve for this. So 15, 4 tangent 2x, 29 times 3, 87 tangent 2x equals to 455 cert 3. Okay, this here we can open up the bracket. It will become 1365 tangent. Okay, wait. 4 plus 87 first. 91 times 15. Okay, 1365 tangent 2x equals to 455 cert 3. Okay, then here we can 455 divided 1365. Okay, tangent 2x will be equals to cert 3 over 3. Okay, everyone get until here? All right. Okay, from here, we want to solve tangent 2x equals to cert 3 over 3, and our range, our domain for x is from negative 180 to 180. Okay, so do like this one now is a trigo. So go back to your trigo knowledge. We have to find what is our base angle, alpha, inverse tangent, cert 3 over 3. Okay, this is in degree mode. So change it to degree mode first. Your alpha will be equals to 30 degrees. Okay, after we have done this, we do our ASTC. Tangent is positive. Okay, and we are also solving for 2x. So x is from negative 180 to 180. 2x will be from negative 360 to 360 degrees. And one more thing, tangent is positive. So AST, quadrant 1 and quadrant 3. Okay, so here, quadrant 1, quadrant 3, our angle here will be alpha. This one will be 180 plus alpha. Okay, so our 2x here will be equals to 30 degrees and 210 degrees. Any more angles? Okay, any more angles from here? So they are saying that the angles is from negative 360 to 360. Okay, so that means like this. 1, 2. Okay, you should get two answers. So from these two answers, the easy way to calculate when you go to negative 360 is you just take these two values, you negative 360 to both of these values. Don't need to go and calculate again. Okay, as in don't need to go and read from the graph here because it's just one whole cycle back. So from here, minus 360 degrees to these two values. 30 minus 360, we'll get minus 330. 210 minus 360, we'll get minus 150. Final one. Divide all of it by 2. So here will be 15, 105, minus 165, minus 75. 5 marks. Cool. Yes, they can mix together both progression, okay, your series and trigo together. It has come out many times. Okay, so trigo have to master, whether you like it or not. Confirm will come out on the solving type of question, and they can come out in different chapters also. Different chapters, different forms. Why minus 360? Because of this domain. See here? You want to solve for 2x. They give you the domain is from negative 180 to 180. Okay, so you have to consider from negative 360 all the way to 360 degrees first. All the way to 0 degrees first. So that means, okay, so in short, how you find for negative one, you have to always check the domain of x that they give you. Okay, then you you calculate based on your 0 to 360 degrees first. Okay, your ASTC first. Then you see if the angles is more than 360 degrees, you take that answer. Okay, sometimes it's 2 answers, sometimes it's 4 answers. 2 answers is when you get either positive or negative value over here. Okay, if it's plus, minus, then you have to take all 4 quadrants. Okay, ASTC. If the value over here is more than 360, okay, maybe until 720, then you will take your ASTC answer, you plus 360 to both the value. Depends on how many cycles. Okay, how many more cycles you have. Can? Fasa, understand? Why are we minus 360? Okay, any more questions for this section here first? Okay. Okay, now last one. Okay, last one I think a bit tricky, but this is similar to the first paper. Okay, the variant one. There was one question. I think was the second last question, which was quite similar to this also. Okay, so let's do as normal first. Only the last part because of this section here, and then they say this sum to infinity. Okay, 6-mark question. So first 3 terms of the progression will be these 3 terms here, where theta is from negative pi over 6 to 7 pi over 6. Find the values of theta for which this geometric progression has a sum to infinity. Okay, has a sum to infinity. So what is sum to infinity? You go to the formula, there's one of it that says sum to infinity. Okay, this part here. S infinity is equals to A over 1 minus R, where your modulus R is less than 1. Okay, do you see here? Modulus R is less than 1. Okay, so we need to use this formula over here. Okay, let me go back here first. We just write it down. S infinity is A over 1 minus R. R is less than 1. Again, modulus R is less than 1. Okay, how do we or what do we need to do first? We need A, we need R. A is 5 cos square theta minus pi over 2. R, you use your second term divided by your first term. 20 cos 4 theta minus pi over 2 over 5 cos square theta minus pi over 2. We get 4 cos square theta minus pi over 2. Okay, don't go and cut off the theta minus pi over 2. Okay, imagine it's like cos 4x divided by cos square x. Okay, we've got our A and R. Now we are, okay, what do we need to find the sum to infinity? They're not asking us to find sum to infinity. So we are going to use this formula over here. Okay, the modulus R. Modulus R is less than 1. Okay, modulus R is less than 1. So R, when we open up, this will become minus 1 to 1. If we substitute in the R, okay, actually do we even need A? Okay, we don't need A actually. Because they're not asking us to find sum to infinity. So I want you all to put here 4 cos square theta minus pi over 2 from negative 1 to 1. Okay, we eventually want to find any theta, so we are trying to solve this. Okay, simplify, so we divide the whole inequality by 4. This will be negative 1 over 4, positive 1 over 4. Then from here, we are gonna square root. Okay, so here will become cos square. Hold on a minute. Okay, cos square theta. Okay, we gotta split it into two. Okay, into two equations over here. Hold on a minute. What did I write here? Let me see. Okay, we will have two equations here right now, okay, which is negative 1 4 cos square. Okay, we will have this one. And okay, can we square root it? Let me see. Can we square root this? Okay, because if you see here, we can get cos. Okay, sorry, teacher forgot what I did already. I did quite some time ago. Okay, this will be 1 over 2. Okay, understand, right? And negative 1 over 2. Okay, this part here, because we cannot square root this, okay, we cannot square root the negative value. So we will only take this part here. Okay, this part. Cos square is theta minus pi over 4 is less than 1 over 4. Okay, because this one math error. So we will ignore this part here. Understand? Okay, from here, how do we do this? If you see in the mark scheme, okay, the official mark scheme, they never really explain what are they doing over here. So if you all follow through from the first paper, right, the first variant paper, I use a specific way on how to solve this question. Okay, so we are going to understand it like that. We want to solve a cos graph where your angles, the values, your y is from negative 1 over 2 to 1 over 2. Got it? Okay, that means from the bottom of the graph, your y is negative 1 over 2 to positive 1 over 2. Okay, so this is how we can rewrite the equation. I want you all to write like that first, to make it simplified. Let theta minus pi over 2 equals to x. Okay, so we will read it like that first. Cos x is from negative 1 over 2 to 1 over 2. Okay, so this is the equation that we want to solve. Okay, now, I would say the easiest way to solve it is you draw out your cos graph. Okay, so here, draw out your cos graph. And I want you to draw from, okay, because you see the angles that we want is from negative pi over 6 to 7 pi over 6 for the theta. Okay, so we are gonna take like this. Okay, this is your cost graph, like this. Okay, then you draw the negative also. Oops. Okay, repeat the same thing. Like this. Okay, this one they want us in terms of pi. Okay, where's the answer? What are your angles over here? Okay, by right, draw a bit more symmetrical. Okay, like this. Okay, where did it intersect? This part here. Okay, this is 0. This one is negative pi over 2. Okay, this one is negative pi. Okay, here is positive pi over 2. Here is positive pi. Okay, everyone understand? This part here. Okay, where is the angle that we want? I draw a little bit bigger here so we can see clearly. Okay, where's the angle that we want? Okay, we want the value from negative 1 over 2 to positive 1 over 2, which is from here, okay, to here. Your highest and your lowest point is positive 1 and negative 1. So here is positive 1 over 2. This one is negative 1 over 2. Okay, so the angles that we want is from this part here. Okay, you see, I'm going to highlight this until this section. Okay, you all look at the angles that they give us also. Okay, we only want from negative pi over 6 to 7 pi over 6. So we'll just take this section here. Now, how do we find this 4 specific point? Okay, you see here 1, 2, 3, 4. Okay, so for this part, you are going to take the base angle. Okay, so I want you all to calculate what's your base angle right now. Okay, cos x is equals to 1 over 2, because this one is 1 over 2, right? 1 over 2, negative 1 over 2, negative 1 over 2. So it's sort of like your ASTC like that. Okay, so but we just base it on base angle. So from here, base angle alpha. Okay, we're gonna calculate inverse cos 1 over 2. Okay, calculate it in terms of radian. This will be pi over 3. Okay, so you will have 4 angles here right now. Okay, we calculate the positive one first. So the positive one, this will just be pi over 3. Okay, so you have 4 angles. The positive part, this one is pi over 3. Then the other angle will be pi over 2 plus pi over 3. Okay, pi over 2 plus pi over 3. So what's pi over 2 plus pi over 3? 1 over 2 plus 1 over 3. Sorry, it's not pi over 2 plus pi over 3, is it? Okay, sorry. It's pi, okay, I also get confused. It's supposed to be pi minus pi over 3. Okay, pi minus pi over 3. That's how we calculate. Okay, 1 minus 1 over 3. So this will be 2 over 3 pi. Okay, so here, because this part here is pi over 3. Okay, so here will be 2 over 3 pi. Okay, so the positive one, the points of intersection with y equals to 1 over 2 and y equals to negative 1 over 2. Okay, so the angle will be pi over 3 is your first answer. Then the second one is 2 over 3 pi. Okay, so the negative side also is symmetrical. So this part here will be negative pi over 3. Then here will be negative 2 over 3 pi. Okay, so you get these 4 angles here. You'll see this yellow section that I highlighted. Okay, now this is the angle. Okay, so this is the angle that we want to solve for x over here. X is from negative 2 over 3 pi to negative pi over 3. Then the positive side will be from pi over 3 to 2 over 3 pi. Okay, we convert it back to theta minus pi over 2. Theta minus pi over 2, which is from this value here, pi over 3, theta minus pi over 2, 2 over 3 pi. Okay, then both the equation, I want you all to plus pi over 2. Okay, everything all plus pi over 2 to find theta. This will be negative pi over 6 to pi over 6. Over here will be 5 over 6 pi to 7 over 6 pi. Okay, I think this is probably the best way to explain this question already. Because, well, yeah, I went and try other ways. Other than using the graph, because typically we don't use this graph, but in your syllabus, okay, if you look in the textbook, actually they got teach you how to base on the graph like that. It's just that most of the time we learn the ASTC method, right? We keep using ASTC, but we need to know how to use this method, which is using the graph itself to analyze the points. Okay, cool. All right, so you all see, go back to variant 1, you all see the paper also. There was one question that was actually quite similar with this also. Also same structure, like geometric progression, and then they link it together with trigo. All right, okay, if you can do this, can you type 10 in the chat for this last question here? So much for $6. Yeah, I would assume that when students did this question, actually a lot of them cannot do. Okay, so there'll be one or two questions that are a little bit hard. Okay, awesome. Okay, I will send this paper to you all. So this is the end of paper 1-2 for ON 2024.